Chapter 15 is more of the bigger picture, right? Remember when I talked about theories, and so there are more holes when you look at the bigger picture. So things, ideas are filling those holes, and so there are certain things that man historically does not know. So they fill those holes with plausible scenarios, right? So the first part of the chapter deals with fossils. First of all, did you know that Kentucky has a state fossil? It does. It has the brachiopod. It's a clam as its state fossil. If you go out anywhere around Frankfurt or Anderson County and you dig up a flat rock, field rock, more than likely it'll have those brachiopods in it. Fossilization is a gradual process that starts with remains of an organism, and that organism becomes buried in volcanic ash or sediment. Sooner or later, water infiltrates the organic remains, the flesh and that kind of thing, and the bones, right? And that those inorganic ions inside the water infuse, and so they make these compounds like limestone, and as more and more sediment accumulates, or more ash accumulates above the burial site, more and more pressure is exerted on those remains, right? And after long periods of time, the pressure forms chemical changes in the sediment and forms rock, right? And since you have rock formed along with it are the remains forming fossils. Right? Fossil is a recognizable physical evidence of ancient life. It can be most of the time hard parts of an organism, such as bones, teeth, shells, seeds, trunks. Or it could be traces of an organism, like impressions of leaves, stems, tracks, trails, burrows, something like that. Now, fossil preservation is favored when the burial is rapid, right? The remains are covered very rapidly. Also, anaerobic conditions must be maintained. Air, oxygen allows for materials to rot, right, to decompose. So if your condition is anaerobic, without oxygen, then it can be preserved a lot better, right? The remains can be fossils if it's entombment. If it's a rapid burial where the volcanic ash and mud or whatever is put over the remains at a rapid rate, right? And once that burial site is maintained over long periods of time, then that burial site must be left undisturbed. If it's disturbed, then air gets to the remains, and those remains then will not become fossilized. And the earth is in certain layers. These layers go according to sediment deposits, right, that have hardened and become rock. And so those remains and that rock layer closest to the Earth's surface is younger very newer type of rock. Whereas if you go deep into the earth, those layers are going to be older, right? And so, if you go out to the Kentucky River and you look up on the Palisades, those rocks that are up at the rim are going to be younger, and those rocks that you're down there by the river are going to be older. All right, so the older fossils are going to be in those deeper layers, deeper strata, all right, and the ones in the upper layers are going to be younger remains, younger fossils. The main events during the history of Earth is called macroevolution, and most of this is based on fossil record, right? So there are several theories about how the Earth came to be as it is right now, and one that played a major role in macroevolution is continental drift. The Earth now has several land plates that are sort of floating on this mantle, which is sort of a semi-fluid layer toward the Earth's core. And continental drift says that at one time there was a large landmass called Pangaea that broke apart, and those plates floated on the mantle until they got to the place where they are now. So this is used to go along with that biogeography that I talked about, where you had lungfish in Southeast Asia and Africa and South America. They look very similar. Everything's very similar about them, but they are different species. And one way to support that is a theory of continental drift. So using geologic time, all right, time scale, there are 4 major geologic eras that have occurred during the time of the Earth. And so the Precambrian era was the one where there weren't many organisms. The first living organisms were like bacteria and small protists and things like that. The next era was the Paleozoic era, where algae, fish, and macroinvertebrates were dominant in the fossil record. The next was Mesozoic, and this is the age of the dinosaurs and reptiles, and cone-bearing plants were dominant. And if you look in the fossil record, the newest fossils are in the Cenozoic era, and that's the one we're still in, where mammals and flowering plants dominate. So for your test purposes, if you know the Cenozoic era, the one we're in now, that's dominated by flowers and flowering plants and mammals, then that's what you will need to know for your test. Right. So there have been mass extinctions between some of these eras. The one most notable that people talk about is the one between the Mesozoic and the Cenozoic era. This is the extinction of dinosaurs. And one theory is that a meteor large enough to impact the weather and the amount of sunlight hit the Earth. There is a impact crater off the Yucatan coast that would be large enough to cause a dramatic dust cloud. This dust cloud would encircle the Earth, reduce the amount of Sunlight cooled the earth as well. With the reduction of plant life, those herbivores would die, and with the resulting herbivores die, the carnivores would die. So that there is a mineral element called iridium. It's very rare on Earth, but it is very common in meteorites. And in the fossil record, between layers, between the Mesozoic era and the Cenozoic era, there is a layer of iridium associated with those rocks in that layer. So that gives credence to this mass extinction theory. So I'm going to stop here. We're going to talk about this in chapter, when we talk later today, just go over how things are organized and categorized, all right? So we'll stop here, and then we're going to pick up the end of chapter 17, because I'm not sure we'll get to it today.